video for AQA Further Pure Mathematics, Hyperbolic Functions, section 1.2, where we're looking at solving simple equations using hyperbolic functions. Well, the method we employ for solving simple equations is to use the definitions of the hyperbolic functions in terms of e to the x, and then manipulate the resulting equations. So I'm going to look at a couple of examples of that being put into practice. The first one is to solve cosh x is equal to 3. So if we have cosh x is equal to 3, we can write that in terms of the definition of cosh, so that is e to the x plus e to the minus x over 2 is equal to 3. And then multiplying by 2 gives us e to the x plus e to the minus x is equal to 6. If you multiply through this equation by e to the x, that becomes e to the 2x plus 1 is equal to 6e to the x. So this is then a quadratic in e to the x. It's equal to e to the x all squared, e to the 2x that is, minus 6e to the x and plus 1. And that must be equal to 0. Now because it's a quadratic, we can solve that in the usual way for quadratics. I'm going to use completing the square. So instead of x, it's e to the x. So we've got e to the x minus 3, half of 6 is 3, so we've got e to the x minus 3 all squared, and then minus 3 squared, so minus 9 plus 1 is equal to 0. And therefore e to the x minus 3 squared must be equal to 8. So we can take the square root of 8, which is equal to 2 root 2, and add 3 to each side of the equation, so that we get e to the x is equal to 3 plus or minus the square root of 8, or plus or minus 2 root 2. This is e to the x. Now the inverse of e to the x is a natural logarithm, so therefore x is equal to the natural log of 3 plus or minus 2 root 2. So there we are with it neatly typed out, and you can see on the graph there of cosh x our two solutions, which are at log 3 plus or minus 2 root 2. In the second example, we're solving cosh x plus 2 sin x is equal to 3. So cosh x is equal to e to the x plus e to the minus x over 2, and 2 sin x is e to the x minus e to the minus x, and that must be equal to 3. Multiplying through by 2 and then gathering together the e to the x's gives us 3 e to the x minus e to the minus x is equal to 6. We've got this trick then of multiplying by e to the x, which then gives us the value 3e to the 2x minus 1 is equal to 6e to the x, and then we can rearrange that to make it a quadratic, so that 3e to the x squared minus 6e to the x minus 1 is equal to 0. Well, there are a variety of ways of solving that. We could, for example, use the quadratic formula, so that's what I'll do here, so that e to the x using minus b is 6 plus or minus the square root of b squared 36 minus 4 multiplied by 3 multiplied by negative 1, all divided by 2 times 3, so 2a, which is 6. And if you calculate that, it's 6 plus or minus the square root of 48 over 6. At the square root of 48, we can take out a factor of 16 from there to give 4 root 3. So in total, that means that we've got e to the x is equal to 6 plus or minus 4 root 3 over 6, or 1 plus or minus 2 over, 2 root 3 over 3. But e to the x must be greater than 0, so e to the x is greater than 0, and therefore we can only have the positive value of that, which is e to the x is equal to 1 plus 2 root 3 over 3. And therefore x is equal to the natural logarithm of that, 1 plus 2 root 3 over 3. And there's the solution neatly written out. And we can see the graph there for the value to be equal to 3, there's only one solution. Well, that's the end of this video, and in the next video we'll be looking at inverse hyperbolic functions.